Yet again, I have a straight line joining those 2 points A and B, and I want to calculate the gradient of that. And so I'm just going to say gradient is equals delta y over delta x, and this here is delta y, and over here I have delta x. It is the difference between the y coordinates of the 2 points over the difference of the x coordinates of point A and B. So this line has the gradient m, but what do I do if I want to work out the equation of a line with gradient m? Well, I can derive that equation from my gradient by saying delta y over delta x, that's my gradient, is just, like we've said, the difference in y over the difference in my x coordinates, and that gives me m. Now, I want to get rid of this fraction. How do I get rid of this fraction? Well, I'm multiplying the right-hand side by the denominator, the thing at the bottom, so I can cancel. That's fair enough, I can do that. But remember, whatever I do on the right-hand side of the equal sign, I have to do on the left. So I'm going to multiply by x2 minus x1 on the left-hand side. Let's tidy that up a little bit. So I have m x2 minus x1 equals y2 minus y1. Let's switch that around, and that will give me y2 minus y1 equals m x2 minus x1. So that's how I can derive the point gradient equation. The point gradient equation, that's that thing over there. Or alternatively, you can just remember y minus y1 equals m, and then in brackets x minus x1. So we're not finished yet. Let's have a look at another function. Here I have y equals x squared. How would I write the derived function of y equals x squared? Well, this is simple. I can just write that as y prime. This is actually one of my preferred ways of writing derivatives, y prime. So here I have y prime equals 2x. I can also write this as dy dx equals 2x, and it's really important that you know that this isn't a fraction. You can't go and cancel d and d, okay? This purely means it's an entity as a whole. It's one entity in its entirety, which means the derivative of y with respect to x. So cancelling is a nice idea, but it's not going to work. So here I have the derivative of x squared. So I'm taking this side of the equation, the derivative of x squared with respect to x, and that is 2x. These are all, I would say, especially this one, these are very common in your textbooks. And it's really important that you know this notation as well. So let's have a look at the derivative at a point. How do these align? So for the first one, you can see these two align. Here I have the derivative y prime equals 2x, and at a point of x equals 3, I'm going to have 6 as my answer. And for the next one, I will write it like this: dy dx at x equals 3 equals 6. So you just draw a long straight vertical line. And lastly, the derivative of x squared with respect to x at the point x equals 3 equals 6. Now we can differentiate roots and also some fractions by first expressing them as fractional and negative indices. Let's have a look. If I'm to differentiate the root of x, what would I do? Well, I'm going to first put that into the form x to the power of a half, because you know there's a little 2 out there which we don't write because it's a square root, and that just becomes x to the power of a half. Always get rid of your root signs and just turn it into an index value first. Very important. Now I'm ready to differentiate by applying all my previous rules. So that becomes a half x and a half minus a 1, or if you preferred 2 over 2. You will notice, and this is extremely important, that I'm not going to leave my answer at that. And the reason for that is I was given a root over here. So I want to give my final answer back in the same format as what was provided. So over here I have minus a half as an index. So that's not good enough. It would have been a different story if this was given to me as an index value, but it isn't. So I'm going to have to change this back into a root. So my first step over here, I'll give you the in-between step. I have a half x to the power minus a half. So I have a half, and 1 over x to the half then gives me a positive index value. And then from this step, I go to 1 over 2, and x to the power of a half is exactly the same as my square root over there. And that is then the correct answer. If you left it at this, that wouldn't have been good enough. So this is extremely important, and I can't stress it enough. Whatever your format in your given question, make sure that is what your answer reflects.